Dear students, in this lecture, let us discuss about the introduction of a device called field effect transistor. Simply, it is called as FET. It is having many advantages over conventional transistor, so that is BJT. Let us discuss those points first. FET is a unipolar device. So unipolar device in the sense the operation of a FET device is depends only on one type of charge carriers. So that is either it is depends on electrons or holes. The current conduction is due to only one type of charge carrier, either electron or hole. Hence this device is called as unipolar device. This device is also called as voltage control device. Why? Because the output current of a device of a FET is controlled by means of input voltage. Hence this device is also called as voltage controlled device. FET is having very high input impedance compared to BJT, and the source and drain are interchangeable in most of low frequency applications. Hence FET is mostly used there, and low voltage low current operations are possible in FET device. FET is having less noise compared to BJT, and the another important thing is it is not having any minority charge carrier storage. Hence the turn off time is very faster compared to BJT. And FET is a self-limiting device, and FET size is very small compared to BJT. Hence it occupies very small space in ICs. FET can be used for low voltage, low current operations, and then it is having a very there is zero temperature drift of output is possible in FET. So these are all the main advantages of field effect transistor over BJT. Here we can see the types of field effect transistor. The FET is classified into two categories. One is JFET and another one is MOSFET. JFET is junction field effect transistor. Again, it is classified into two categories according to the type of charge carriers used in that FET. One is N-channel JFET and another one is P-channel JFET. And MOSFET is also called as IG FET. So that is insulated gate field effect transistor. MOSFET is metal oxide semiconductor field effect transistor. So the MOSFET is again classified into two categories. One is enhancement MOSFET and another one is depletion MOSFET. Again these two categories are classified into two categories again. One is N-channel enhancement MOSFET and P-channel enhancement MOSFET. Again D MOSFET is classified into two categories, N-channel D MOSFET and P-channel D MOSFET. So in this lecture, let us discuss about JFET alone. So before entering into the JFET category, we already have discussed about BJT. So that what is current controlled amplifier? That means the amplifier which uses a current control devices called current controlled amplifier. So BJT is a current control device because the output current of BJT is controlled by the input current. Hence this device is called current control device. And the amplifier which uses current control devices are called current controlled amplifier. And voltage control amplifiers. We all know that what is meant by amplifier. The output voltage or current will be more than the input voltage or current. That is, output value will be more than the input values. Then it is said to be amplifiers. So here voltage control amplifier in the sense the amplifiers which uses voltage control devices called voltage control amplifiers. Then what is voltage controlled devices? Which is nothing but the output current of a device is controlled by the input voltage. Then it is said to be voltage controlled devices. So we can explain voltage control amplifiers or the amplifier which uses voltage controlled devices. So here we can see the constructional details of junction field effect transistor. So it consists of three terminals. So that is source, drain and gate. So source, the name itself, it says that it can supply charge carriers to the devices. So that means the terminal through which the majority carriers enter into the channel is called source terminal. Simply it is termed as S. And drain, the terminal through which the majority carriers leave from the channel is called as drain terminal. Simply it is called as D. And gate, there are two internally connected heavily doped impurity region to create PN junctions. These impurity regions are called the gate terminal G. So these are all the three terminals available in junction field effect transistor. Then what is channel? The region between the source and drain sandwiched between the two gates is called as channel. So depending upon this channel, the junction field effect transistor can be classified into two categories, that is N channel JFET and P channel JFET. Here we can see the constructional view of JFET. So two internally connected P regions are taken as gate, and in the upper side drain terminal is there, and in the channel lower side source terminal is there, and these terminal are taken to the outside connection through the ohmic contacts. So this is constructional view of JFET, junction field effect transistor. And here we can see the labels of N channel and P channel JFET. So again I am repeating, JFET consists of three terminals, source, gate and drain. Depending upon the channel classification, it is classified into two categories. One is P channel and another one is N channel. Here we can see the symbolic representation of N channel and P channel JFET. In N channel, you can see the gate arrowhead inward, and in P channel the gate arrowhead is outward. So with this symbolic representation we can identify which one is N channel JFET and which one is P channel JFET. And we can compare the JFET analogy with water analogy. So from this diagram we can see that if gate is fully open, the water can flow from source to drain. If we control the gate, that is if you are closing the gate, the water flow from source to drain will be will be reducing, isn't it? So if the gate voltage is the gate is fully closed, then there will not be any water flow from source to drain. So the same way we can explain the JFET operation. Here we can see the operation of JFET. Initially there is no voltage sources given to the JFET, so at that time the channel is fully free, so that the current can flow from drain to source without any disturbance. Now while increasing the supply voltage, the gate will be closing, so that the current flowing from drain to source will be controlled, so that always the electrical analogy will be compared with the water analogy. You can see the operation here. Now I am applying voltage, so that the channel is getting reduced, so that the current flowing from channel to, that is current flowing from drain to source will be reducing. Again I am applying voltage, the channel width is getting reduced. So if sufficient voltage is given to the gate, then channel is fully blocked, so that the current flow will be 0. That is, from this case we can Understand that if gate is fully open, the current from drain to source will be high. If the gate voltage is given to the JFET, then channel width is getting reduced, due to which the current flowing from the drain to source will be reducing. So that from this category we can, from this explanation we can understood that, we can understand that if the gate to source voltage is going high, then the current from drain to source will be controlled. Hence this device is called as voltage controlled device. That means through gate to source voltage we are controlling the current flowing from drain to source. And here we can see the comparison between FET and BJT. So FET, it is a unipolar device, BJT, it is a bipolar device. Unipolar in the sense the current conduction is due to only one type of charge carriers, either electrons or holes. In BJT, it is a bipolar device. So BJT in the sense bipolar junction transistor. Bipolar, that is the current conduction is due to electrons as well as holes. Hence this device is called bipolar device. And FET is a voltage control device. That means the output current is controlled by input voltage. BJT is a current control device. That is the output current of BJT, that is collector current, is controlled by the input current, that is base current. And in FET the input resistance is very high in the range of mega ohms, and in BJT the input resistance is very low in the range of kilo ohms. And FET is having negative temperature coefficient and BJT is having positive temperature coefficient. And FET will not be suffer by minority charge storage, but in BJT the minority charge storage problems will be there, and it cannot be used for lower switching speed and cutoff frequencies. And FET, it is having less noise and BJT is having more noise. And FET is much simpler to fabricate and BJT is little bit difficult to fabricate as an IC. So this is the these are all the points, the comparison between FET and BJT. Okay, thank you.